Hello and welcome back to another video from the Block IoT. Today is a very special day because we have Randy Armstrong from the OPC UA Foundation, an expert in industrial Internet of Things with us. And I just want to say thank you very much, Randy. I know you are a very busy person, and I've been talking to you to make this happen for a long time. And finally, we made it. So thanks again for joining us today. And let's just kick the session by just an introduction, perhaps. Could you just tell us about yourself, your background, and your current roles? What are you doing right now? Where are you located, and so on?
Well, I the chair of the OPC UA Security Working Group, and I've been heavily involved in OPC specification development for over 20 years now. And I do a lot of different things for the OPC Foundation, including doing prototyping. I take care of some of their IT infrastructure. Now, I originally got into OPC back in the 90s, and I was working for a startup. And I don't know if you remember what the startup scene was like in the 90s, the first boom, but and we had a Raspberry Pi like board, and we wanted to we were trying to find ways to get customers. So we were looking at developing software and services to try and make an interest. I knew I had some experience with factories because I was an electrical engineer, and I did some co-op terms, and so I saw this spec called OPC. It was a new spec at the time, and I thought, hey, it will be cool to get this thing running on these devices, so we could potentially sell it as a board into that could be used in the factory. So you could just hook up your OPC supporting HMI and talk directly to it. So, but DCOM didn't exist on these OSs. So I developed a tunneler application, and that worked reasonably well. I ended up getting a patent for the idea, but it's been long since expired. But that's how I got into OPC.
Nice,
So
pretty. Yeah, that's pretty interesting to know. I didn't know your background is also electronics and electrical engineering, and it's pretty cool because that's where I am coming from actually. So it's just some background in electronics, also designing some embedded system. It was just fun time. I also enjoy it. Still, I really enjoy like it's fun to see how innovative product came out like Raspberry Pi you mentioned, Orange Pi. Just too many of them these days. So it's pretty cool.
yeah. Well, this is before any of those boards even existed.
Oh yeah.
This startup was doing lots of interesting things, but it got wiped out in the crash in the year 2000. So,
Okay.
like a lot of other startups.
No, I hear you. Yeah, pretty fun time those days. So, yeah, thank you very much. That was a great intro. I think my second question was about how did you get involved in OPC, but you already explained that, and it was pretty interesting. So, you didn't join, let's say, from the day one. The OPC was there, and you heard about it, and you were kind of got interested into it, and then you started using it and learn more about it. Is that right?
Yep, exactly.
Okay, that's perfect. Yeah. So, coming back to the question, and let's just start with some maybe definitions and some basics of the OPC UA. And so overall, just to give you like the overview of the following questions, I'm not sure you follow Block IoT, our YouTube channel, and also a community on LinkedIn. Actually, we got the community grow up significantly recently on LinkedIn. I think we are over 4,000, and on YouTube is over 2,500, I believe. So
Wow, that's
yeah, it's
pretty
in.
good. That's pretty good for an OT
Yes, exactly.
podcast.
So yeah, thanks everyone for following us. So yeah, let's get back to the topic. So overall, I posted basically a question, or let's say announcement on LinkedIn of the Block IoT, and we asked the community for question because these days OPC UA, Industry 4.0, and all these topics are a little controversial. Everyone has its own opinion, and there are just, I would say, a lot of misinformation and good information out there. So we wanted to make sure every question is answered. So about the OPC Foundation, let's see, what is OPC Foundation at all? Like, who are its members? Like, is OPC UA open source, or is it like a part of a private organization? And another question that I get asked is, does companies like Microsoft or any other company owns or even influence OPC Foundation? Like, what is going on exactly?
Well, the OPC Foundation is a member-driven corporation. It started because you had a bunch of automation vendors who were getting their proverbial butts kicked by wonderware in the automation market, and they needed a solution. So they got together and they said, "How can we fix this problem?" And that was the genesis of OPC. Well, today the OPC Foundation is primarily it's a nonprofit organization that manages the standards. It's an SDO, or Standard Development Organization, and it's responsible for promoting the use of the standard. Now, it has a lot of members. We've got over 1,000 members now, including every major automation industry automation product vendor, as well as many major, I think most major IT companies that are looking to sell product or services into the OT market. Our membership is global. Everywhere, a significant chunk of our membership is split around between Europe and Asia, even a few African and Indian, actually a growing number of Indian members as well. Of course, obviously North America is a big chunk of the membership as well. So it is a global organization. The committees themselves work by consensus, and basically what it means is you sit down, you talk through issues, and you try to come up with a decision on what the best way forward is. Now, some people hate this kind of approach because they would rather, oh, somebody has to take control and just make decisions. Well, that doesn't work so well if you're trying to make a standard. And so what this also means is that no one company has absolute influence over the spec. Like, people will come, different people will come in and say, "Hey, I got this important use case that we'd like to solve," and the committee would sit and say, "Yeah, we agree with you. We think that's something we need to solve." But it's not just the committee members. Sometimes what happens is you'll have a major vendor or major end user will come up and they'll say, "Hey, we've got this problem that's really bugging us." And in some cases they might even get invited to a meeting to present the requirements to the committee and say, this is our problem. This is what we'd like to have solved, and then we will sit down and try to figure out how to do it.
Okay, perfect. Yep, that's I think clarifies a lot of questions. So yeah, it's just an NGO and or a standard organization. No other company has a direct influence on this foundation. Perfect. So a little maybe I'm not sure. We don't want to go deep to the technical right now with this question, but I just wanted to ask, like, why do we need a standard like OPC UA in the industry? Maybe if you could kind of have a flashback to the industry and provide a quick history of OPC UA overall the revolution. Like you said at the back in the time that you had the startup company, you heard about it. Like, what was the need and what's basically what kind of attracted people to even look at it or think about something like an OPC?
Well, it came down to being able to get in, reducing the cost of entry into a market. So what happened was in the 90s, the market was dominated by one company, Wonderware, and nobody else could afford to get into it because they just didn't have the engineering resources to build all the device drivers for the literally tens of thousands of different unique pieces of factory equipment. OPC broke that monopoly by providing a standard interface to the devices. So now what happens is the device vendors would produce their OPC server, and then somebody else like Iconics or would come along and they would say, "Oh, well, okay, I'll just write my client that talks OPC," and now all of a sudden they're no longer responsible for developing all these device drivers, and you've got this huge market that's available to them. And so by doing something as simple as putting in a standard interface, in this case, leveraging off Windows infrastructure, which was a great decision at the time because in the 90s, PC-based control, that's where the industry was. It seems almost laughable now, but that's what it was at the time.
That's right.
um, but OPC has evolved as the market has evolved, and has as but its mission remains the same: providing standards that reduce the cost of deployment and development and deployment of solutions, and allow end users to buy products that they can drop in and have them communicate with each other without having to spend a lot of engineering resources developing custom code. And this is actually one of the main pain points that we see in the OT world today. You have a lot of different device vendors coming out with what they claim are open standard interfaces. So they'll say, "Hey, I've got a web server on my device, and you can use this REST API," or "I've got an MQTT thing. Here's how my message formats and whatnot." But ultimately, what they're doing is they're simply creating a custom API that people have to program against, and every device is different.
Yes.
And and of course, it is layered over an open internet standard, which in theory makes it easier. It's not like the bad old days where everything was a binary protocol that you had to mess around with. But and there's a lot of tooling to support these different things. But this has created a huge market for these aggregators who want to be the hub of everything in the factory. So they sort of are replacing. They're like the Wonderware of today, where they're trying to get all this data into them and then distribute it wherever you need it, but effectively making themselves essential to the factory. And that creates kind of a lock-in for factory owners. They can't just simply get rid of these hubs. It's much better for them if they had an environment where all of their information was being exchanged using standard formats, and they could drop in any number of different software, and they'd all communicate. And they don't need to develop custom software to in order to consume this information, or either produce or consume it. And that ultimately is what OPC UA is doing.
The customization, basically, overall, as you know, it's always a pain. Like when you want to customize and write your own to integrate one piece of software or hardware to another, it's just confusing. And overall, especially when you're selling something as an equipment, standardization is very important. So that's, I think, where the OPC UA or any other standard comes into the action. So that's great. And like for those who are not maybe familiar with OPC at all, so if you maybe in just a few words and sentences you could say, because we had a like older or classic OPC UA or OPC DA that we called him at those days, and then we got the OPC UA, which is unified architecture. Do you remember at what year was that the OPC UA was kind of got introduced, and what was the need for this switch over?
Well, the need for the switch over was PC-based control was dying. Nobody wanted to put Windows PCs. People wanted Linux. They wanted the web services to take it off. Web services was a big influence on early OPC UA. This is back in 2002, 2003. So we needed a new generation, and so we took a lot of the lessons. Like we learned a lot of hard lessons from OPC Com, and we incorporated those, and a lot of those things got incorporated into the design of OPC UA. And a lot of people don't appreciate it when they look at the spec, and it's done in a certain way, and they don't understand the history that we have with real world experience of people deploying real applications that has gone into a lot of the design decisions that are built into the specification.
If you want to define OPC UA, because one of the questions that we got, I mentioned on LinkedIn, we asked that, or we announced for people to ask their question. One of the readers, Matthew on LinkedIn asked, it looks like there are various definitions for OPC UA. Like just a few examples he gave this, like, is it a modernized version of OPC Classic, or a collection of advanced services, or a flexible communication platform? So overall, what's the definition, or how do you define like OPC UA? Is it like you define it as one standard product? How do you define it?
I would describe it as an ecosystem that combines standards at multiple levels to create a coherent framework for the distribution of OT information. One of the trends that I've sort of seen going on in the last 10 years, that the actual protocols are becoming less and less important. What you need is a standard way to exchange the information, and whether this information is going out over a REST call, going out over MQTT, or going out over OPC binary protocol. Being able to have standardize that information model in all these different mechanisms, all these different formats, and all these different encodings adds value, because you're not doing translation. You're not, again, it eliminates a lot of the need for custom glue logic, which of course consumes a lot of time. And so ultimately, OPC UA is an information standard
Information standard.
that that provides mappings to different protocols, so you can get plug and play interoperability. Because without the protocols, you don't get the plug and play. So we're starting with information. We have mappings to protocols, and that's what we offer.
Okay, perfect. So I think you briefly had a touch on this word or term, but I wanted to ask, like, what are the OPC UA specifications and companion specification, and how are these structured, and what are the different parts, and why there are just several parts? Like overall, that's one of the controversial topic that some people talk about. If you could kind of shed some light there.
Well, yeah, it's well, the core specs themselves, and you have to remember the OPC UA specifications are divided in basically two broad groups. The core specifications that define the meta model and the protocols, and that's 3, 4, 6, 11, and 14.
Okay.
So those are the basic infrastructure. Everything that is in UA is defined in those specs. Everything else are basically information models that build on it. So we defined the meta model, and we said, okay, now we're going to use our meta model to create a description of alarms and conditions that you can use in the factory. And that's part 9. We're going to create a meta model for uploading files to your device. That's part 23, I think, and so on. So all these different, all the other parts are simply specialized information models to address very specific use cases that we felt were common enough to justify having a OPC release specification.
Okay.
Now, beyond that, you have this entire, I say, community of people developing their own information models that could range from for their own purposes and for the particular factory to meet their particular needs, or maybe they're developing it for the vendor, for a particular vendor product. They've created their own information models that's constant across all the vendors. You get collaborations in specific verticals, like oil companies, or tobacco manufacturing companies, or laboratory analytics companies. They get together and they say, hey, we would like to have something that works for our data, and then they create their own information model.
Okay. Perfect. And these specification, I think they are available online on your OPC website. Is that correct?
Oh yeah,
Yeah.
well, yeah. Right now we've got everything. Everything's online with yeah. The reference.opcfoundation.org has all the specs are
Okay.
available there.
Backing into the topic of custom application or new product. I know you're expert on that one. Let's say I'm a device manufacturer or a software manufacturer, and I want to add OPC UA functionality to my product. Again, as I said, it could be software or a piece of hardware. So the first question that I would ask is, where do I start? Like, who should I basically reach out to? Is this like a sales team out there, or is there any like a resources available there that I should consult with, or do I need to follow all the parts of the OPC UA specification, or how does it work overall? Let's say again I have this maybe a piece of hardware and I want to basically customize it, build my own PLC, let's say, and I want to say, okay, I'm OPC UA compliant. So where do I start?
Well, the first thing you'd want to do is you'd want to identify an SDK that will run on your platform. And they're open source SDKs, they're commercial SDKs. If you're starting with an SDK, all of a sudden, most of the specification you'll never have to read, never have to think about. And we've been encouraging a lot of different vendors to develop it. And I think, as far as as last count, I think there's at least 10 or 15 different SDKs available of one source or another, plus that are in reasonable shape, and a whole bunch of others that seem to be projects that haven't been maintained. So I wouldn't necessarily recommend it. But the point is that you start with an SDK in the language that you want to use, and you work from there.
Okay. And
And
mhm. Yeah, sorry for interrupting. On top of your head, do you remember like what languages are available, like different SDK for right now, or?
Or you can get SDK, well, you can get ANSI C, you can get Java, you can get .NET. I believe there's a Python one available. There's JavaScript, a very popular one that uses Node.js. I think that covers the major languages. I think
Yeah.
I think somebody's working on a Go version, and I'm not sure what state that one's in. Um, so the there's lots of different options. Now, one of the things though, and we'll get into this, maybe get into this bit later, is we've in the next release of the spec, which should be coming out any day now, we've moved towards a leveraging off existing tools, in particular Swagger. So we're hoping towards getting to the point now is where you'll be able to build your UA applications by using standard tools that standard tools that are based on the Swagger Open API definitions, and that would give you your starting point.
That sounds great. Yeah, perfect. And just a quick follow-up question to my previous question. Like again, this is a question that Matthew asked on LinkedIn. So is it ever like acceptable for a product or like a soft piece of could be again hardware or software to advertise itself as an OPC UA compliant without specifying the details? Like if yes, like if you think that's the like if it's okay totally, what are the is the or is there any minimum functions that it should be implemented so they can call themselves OPCUA compliant? And is there any some sort of let's say official labels that OPC Foundation provides for different product data sheet and overall, yeah, about the compliance, that's kind of a gray area that there are a lot of question about.
Well, anybody can implement a product and claim that they implemented the OPC UA specification, but that is too broad. What people need to do is they need to be very specific about what profiles they're supporting. So they could say they implemented the standard server profile, or they implemented the alarms and conditions profile. And so we've been a lot of the work that the OPC Foundation has been doing has been educating people about how you need to ask. It's not about asking for 1.04 the specification and whatnot. No, you have to think about what you need and say these are the features we need, and here's the list.
Yeah. Okay.
And that's a little bit more complex than what people are used to, and this is what vendors have to get used to. If they want to communicate what they do, they need to list the profiles that you support. Now, when you start getting into compliance and certification, you're going to run into some issues because we do have trademarks that if you want that only products that have gone through the certification process can use. So we have a test labs. You can take your product into test labs and you can get it certified. And this is actually a very good part of anybody's developing a UA product. You'll find that taking it to the test lab isn't just valuable in terms of getting the certification so their customers have more confidence that they've implemented the specification properly. It's also a useful QA process. So effectively, you've got external testers going at your product and potentially identifying issues that you hadn't found already, that you would have turned into a bug in the field if you hadn't discovered it.
Okay. That sounds great. And I know because the OPC UA Foundation, again, the members are kind of, volunteers and there are limited resources and all this, testing and certification needs a lot of resources. So you mentioned there is a lab and there, manufacturer, they can go through this certification. Like for this particular one, what's the starting point? Again, they should shoot you an email or how do they start?
Well, there's actually, you can go to I believe the certificate. It's OPC Foundation /org.certification. Basically, there's a link on the site that sort of tells you all about what you need to get into that and where you can request more information. Um, obviously, testing costs money, but if you want to put out a product, especially in the OT market where reliability is very important, so the labs themselves are run on a cost basis. They're not we've specific policy. We don't want our labs to be profit centers. They're just there to help people. But obviously, since you have to have engineers doing the testing, there's a cost involved.
For sure, and it's not just about the OPC or OT, as you know, like UL or CUL in Canada is the same thing. If you want to certify something, you have to pay for the resources and get that label or certified, basically.
Yeah,
So,
but actually, I worked at CSA in a previous lifetime, and the important difference between OPC and an outfit like CSA is CSA standard making is for profit. They are for profit company,
okay,
as well as testing is for profit.
okay, good to
That's
know.
not what OPC. We're basically a nonprofit. Our job is to make life better for end users in factory automation by reducing cost and providing standards that make that possible.
Okay. Oh, that was a great point. Yeah, thanks for bringing that up. And just the last question about this definition and basic section I can ask is there any licensing fee for using OPC UA either as an end user or a manufacturer? If there is,
Absolutely.
yeah,
Absolutely none. OPC has always been completely free to use by anyone. No requirement for membership to develop a product. The specs are all publicly available. We, of course, obviously encourage people to become members. We encourage people to get certified because, like I said, we see that as a valuable part of their own QA process to make sure that their products work the way they should. And but one other aspect about the OPC Foundation is we've updated our IP policy, and we've got one of the best IP policies in the industry in terms of protecting people who use the specification from patents being held by different players that may wish to exploit the standard people who implement standards. Obviously, no protection is 100%, but everything we've heard from lawyers say yes, this is a pretty good. It's a provides some pretty broad protection. There's other videos available and other materials on YouTube that you can get if anyone wants to get more information about how that works.
so, Randy, let's move towards maybe more technical question and answering or debunking, I would call, some misconception about OPC UA. And again, I would just ask a few questions with some follow-up, and feel free to change it and restructure it as you would. So the first question that I would ask is, or I hear especially online with some argument, some people say, is OPC UA really too complicated, as some suggest, because it has features they don't need? Or is there any counterpart with similar features that is easier to use? Maybe perhaps, again, people compare MQTT, for example, and OPC UA. They say, oh, it's easy, so why do I need OPC UA? So what do you think? Is it too complicated?
Well, okay. Well, the first part of it is a subjective opinion, and everyone's going to have their own opinion. The fact is, there are a lot of people who've gotten into UA and they find it very easy to use. The Laboratory Analyzer Group, which is a consortium of all the major laboratory equipment producers around the world, have been developing an OPC UA standard based on OPC UA. They have requirements that preclude the use of something like MQTT. So they doing everything based on UA client server, and they had their UA servers. They had a workshop, and they had everything up and running within 2 days with their custom information model. And there's a OPC Foundation video sort of highlighting this effort. So it is possible to put together some pretty compelling solutions pretty quickly with the right SDKs and the motivated people who understand how to use OPC UA. But the other caveat, I'll say, it's always possible for somebody to come in and say, I've got this very, very narrow set of requirements. So I'm going to say it's easier for me to cook up my own little custom REST API or put together some JSON messages that I send out over MQTT, and it solves the only thing it solves in my are my requirements as they happen to exist today, and yeah, there's always going to be people who do that, and in some cases it might make sense. But in the broader picture, people need to have a certain amount of humility and understand that your requirements that you have today are not going to be the requirements that you have tomorrow.
For sure.
And if you go down the path of doing custom engineering to solve your short-term problem, then you're forever locked into this process of custom engineering. Every time you want to make any change or any update to your requirement, or if you start to get more complex use cases come in, then it just explodes over time. And people have companies over time, there's been story after story after story of companies that find themselves 10 years down the road with this massive amount of custom code that they can't maintain and they don't know what to do with.
True.
So anybody who sits back and thinks about the problem should realize I should be starting with a standard. Yes, because it is so broad and it tries to solve a lot of different problems, there's going to be a greater step to get over the initial hump. But once you're there, once you've got that knowledge, then you can start developing all your framework. And then all of a sudden, if you need some new piece of functionality, guess what? You never realized you needed a way to upload files to your device originally, but now you've got a standard information model that you can just grab. You don't have to write a bunch of new code and define new APIs.
Yeah.
So it comes down to mindset a lot of times, and I understand that because I've always been somebody who loves to sort of hack together a solution to a problem. Hey, look how fast I can put it together.
Yeah.
But over time, I sort of realized that these hack together solutions are never a final product. They're not even they're not even close to it.
Exactly. Yeah. I've also seen a lot of customer like that. Like they are happy that okay, we say just a little bit of cost and time, they put together some piece of code and they just have a product running. But as you mentioned, in the long term, after a few years, the company or the person that wrote that code doesn't really exist anymore and you can't find them. So what's the solution now? You have to just go through and finding that maybe nail in the stack of hail is just crazy. So a standard, that's why we need a standard. So that's the art of
Yeah.
using a standard. So great,
Yes.
great answer for that. And another claim that I also hear online a lot is again, we already talked about, some people say OPC UA is complicated, is huge. And some people say or claim that 80% of OPC UA specification aren't implemented by vendors. So they conclude that this means OPC UA hasn't been widely adopted. How do you
Yeah.
think about that? Yeah.
This is an infuriating, completely deceptive statistic spread by people that just wanted to spread FUD about UA for whatever reason. I don't really understand their motivations, but um, if you go look at the OPC Foundation feed, you'll find a post that tries to answer this particular question more fully. But the first thing you need to understand, as I mentioned before, is the base core specification is like Swagger. It defines a way to describe APIs. And the companion specs are like all the different Swagger APIs that people have developed. So what this statistic is trying to do is you should judge Swagger, the success of Swagger, not by the number of people that are using it, but by the percentage of APIs that people have developed using it that are actually in use.
That's a good
And,
point. Yeah.
and it just makes no sense to me. And it's absolutely, that's why I find it very infuriating.
Yeah.
But one caveat when it comes to if you actually want to have sort of successful information models, and what we've learned is there needs to be a cohesive industry group or people with a common interest that to get together and agree on an information model. And the most successful information models have been things like MDIS, which is a group that works on the interface between offshore well platforms and the ground-based controls, DCSs, and the tobacco machine communication is another information model that is pretty much getting deployed in every tobacco company around the world. Not a popular industry, but it's still heavy duty manufacturing. And then another one is laboratory analytical devices. Again, they have lots of complicated equipment that measure that is used for QA processes in drug manufacturing and a number of other things. But what happens is you have all of these groups. They come together and say, "This is we need a common solution so we can reduce our software development costs." And they agree on it, and they develop products to do it. And so now, if you want to go and you're building a tobacco factory, you've got a selection of products that you can go out and get. But the thing is, these successful information models are so narrow and so focused that you're not going to see a generic product that supports them because there's no need.
Right. Mm, that's right. That makes sense.
So if you're going to look at the data show, it's like, now what's happening now is a lot of product vendors are sort of understanding the value of information models. So you're seeing more and more products coming out now that are providing not only the ability to sort of ingest any information model, make it appear in the UA server, but ways of extending it using some sort of scripting mechanisms to provide some back end capabilities. So as OPC UA matures, you'll see more and more of this, which will make information models more powerful. But ultimately, they are extremely useful and extremely powerful when, and they say then in these when they have the support of a core group of core industry actors. But more importantly, the core OPC UA specification basically replicates what OPC Classic did. So even if you never use any information model and you take any OPC UA server, it will allow you to do basic data access. And 90% of OPC applications back when OPC Classic was used were data access.
That's right. Yeah.
So there's a huge market for people who just need data access.
Yeah.
And that's good enough for their purposes. So by having this layered architecture where you have the base capabilities that does provides interoperability to a lot of people, and it says, hey, if you've got these advanced use cases, here's these capabilities that you could take advantage of when you're ready to.
I think we already touched this topic, or my next question about like the why we need OPC UA, of course, to avoid in the customized code. But with MQTT, I know we can't really directly compare MQTT and OPC UA, but a lot of or many user, that's what I at least hear, is they say, with the MQTT simplicity, it's very simple to use MQTT. Some believe it makes OPC UA unnecessary. That's just an argument, and particularly in IoT application. Maybe in your word and in your experience, could you just very briefly explain the difference between MQTT, which is merely a messaging protocol, right? And OPC UA as a data modeling framework and comprehensive standard. So if someone say, okay, I'm just going to use MQTT, not OPC UA, what's the problem with that statement?
Custom code.
Yeah.
you're just going down the rat hole where you're going to be developing a bunch of custom code to handle your messages, and it's a false dichotomy to talk about OPC UA versus MQTT. MQTT is part of the OPC UA architecture. So we have pub sub is part 14. It's a standard designed to work with many different sort of middleware. MQTT is one of them, and so we have a mapping that takes advantage of topics and provides complete mechanisms for discovery using a metadata and the publisher discovery using specialized topic names. And OPC UA takes advantage of it. So, but the point is, all the features that you get from OPC UA off the shelf with OPC UA over MQTT, you would have to code yourself manually. So it's easy to say, oh, I've got this data. I'm just going to create a JSON message or a protobuf message, and I'm going to send it to this topic. Okay. How about a standard way to discover what publishers are out there? Well, that's a bunch of complicated stuff you have to engineer, but OPC UA's already engineered it.
That's right. And security is also a very top aspect. That
Yeah. MQTT with security things get a little
I know.
dodgy there at the best
Yeah,
of times, but or if you want a way to describe the contents of your messages using a standard format, again, you got to build that from scratch.
yeah, that's right.
Uh,
So
so that's why that's the value you get by using OPC and of course OPC UA with MQTT, and of course because it's part of the ecosystem. So what ends up happening is that you can have your UA server that's running. So you got your SCADA client talking to your PLC or some other devices on the floor, and they're doing what they've been doing for the last 30 years, and they're doing it well.
yeah,
But you need to get this data up to the MES, or you need to get it to the cloud. So what happens is you just start picking the data off the OPC UA server and publishing using OPC UA messages with the same context, with the same names, with the same links back to the information model, and that's getting all the way up to the cloud with no translation, no protocol mapping. It's consistent.
yeah. By now, I think everyone who listens to this podcast should know that why it is very important to consider something like OPC UA, not just say, I will use MQTT, avoiding custom code. But I'm not sure you're familiar with this new, relatively new standard, which is MQTT Sparkplug B. So this is something that, again, because I know you're expert in OPC UA, maybe you can add more context here. But with the MQTT Sparkplug B, which basically trying to add a structure and a state management to MQTT, do you think it could kind of replace OPC UA to some setting, and how does OPC UA differentiate itself in terms of like high level features like data modeling, scalability, security?
Okay, well, the short answer is OPC UA over MQTT does everything Sparkplug does plus more. And in some cases, it does it better. And this, in part, is because of our decades of experience working in the OT world. We avoided some of the traps that Sparkplug fell into. So they've got a problem with their with under certain conditions, you can generate data storms that can take down your historian, and there's numerous other sort of architectural issues that are sort of baked into the Sparkplug protocol, because they were just coming along from the position, oh, we can make something really simple for people to use, so we're going to pretend that we know everything we need to know and hack together something very simple. And of course, once they start rolling that out, they start to realize that their initial assumptions weren't necessarily valid for a huge number of use cases. So Sparkplug has these limitations, I guess it's being used in certain environments. But we're finding from our conversations with all of our major vendors is that they like OPC UA Pub Sub a lot better because of it's tied into the OPC ecosystem. It's got a support of a large number of major automation vendors as well as cloud vendors. We've got the new cloud initiative, which is just an umbrella where we're bringing together end users, in particular Alibaba, AWS, Microsoft, Google Cloud, UI, all of these major IT vendors, and we're basically saying, okay, let's figure out how we can make sure that all of the solutions that we have are cohesive and deliver value, and basically allow people to get their data into the cloud with the context that they need to understand it, and minimize the amount of custom logic they need to do any sort of processing with the data.
And just a follow-up question about my previous question about Sparkplug B and OPC UA, and some claim, because I personally try to educate as much as I can. Like for example, one question that I simply ask from those who criticize OPC UA, that say this is the problem and so on. I always ask, we all know what's the problems or existing issues with a Sparkplug B. Why you don't complain about the same thing in a Sparkplug B? An answer that I see is, they say OPC UA members don't engage with the community and as much as other groups like Sparkplug B. So a question that I wanted to clarify: how can people reach out to you and OPC UA Foundation members to perhaps provide feedback, ask question, or contribute? Of course, what personally, because we didn't have any previous relationship. What I personally like, I reached out to you, I requested for your time for this podcast, and you agreed, and which is clearly says you care about the community and the question. But what do you think? Like, what's the best way, basically, people can reach out to you and OPCUA Foundation?
Well, the the OPC Foundation has always had open processes that are available for people to participate. We've got all of our specs are available. We've got a bug tracking system. Anybody can put stuff in there. I guess what we sort of realized is that we don't have as many hyperactive social media influencers out there on YouTube and LinkedIn, sort of talking about OPC Foundation, and we're trying to address that. But to say that we don't engage in the community is, I think, a false statement. Yes, because for example, with the field level initiative, FLC, started in 2018, we brought together over 360 experts from 65 companies, and they developed the initial concept, and that's a pretty big engagement in terms of pulling in people, a diverse group of people. But we did it through the traditional ways, and it's all part of this our entire world is changing constantly, and sometimes the old ways seem a little stodgy and out of touch to younger people who've grown up with the new ways, but they still were effective. They still did that, and and we still have a large number of good participation. A lot of our working groups, and like I said, we've got 1,000 members right now, and so I just think it's simply false to say we don't engage. We don't necessarily engage in exactly the same way as Sparkplug B people do. And again, we're trying to realize that the world has changed, and we're working towards getting out there and talking more. Um, but the short answer is, anybody who sends me, in fact, this may be a good anecdote. Somebody posted a bunch of issues with the spec on the OPC Foundation forum. I looked at it and said, "Yeah, this is just a sort of a random person. Yeah, these are good issues. These make some good points." And I point him to the Mantis issue. Here, please put him into the Mantis issue. We just last week, we'd gone through them all. We closed them. We'd updated the spec, and the release is going to be coming out. Is going to be taking into account all of these issues that this guy brought up.
That's great.
So, pretty direct link between just a random person on the internet providing useful feedback and that feedback actually making it into the spec. It just happened to be good timing. It was so quick, but
Yeah.
ultimately the processes are there if people want to participate.
That's good. I think you just mentioned, because I didn't know that there is a OPCUA forum that people can go and talk to each other and post their concern and so on. That's great. Great to know. All right, Randy. Thank you so much for the answers so far. And let's just dive more into the more technical question that we received through the LinkedIn and also the YouTube channel. And some of the question was very interesting to me also. I didn't know the answer for those, so it would be great if we hear your opinion and answer. So one of the first question. So basically, OPC UA supports various information models from different vendors, right? What challenges arise in ensuring true interoperability between basically these models from different vendors, and how is the working group at OPCUA addressing this? Basically, how you can make sure all these information models from different vendors are can work with each other? Is there any, like, again, I think it comes back to the testing process and so on. What do you think about that?
Yeah, you have to treat information models as kind of a series of Lego bricks. So you can take pieces of an information model and you can incorporate it into a larger information model. And so by standardizing a lot of the pieces, you actually get a lot of interoperability. So something as simple as a standard property for engineering units. It's you don't think about it, but if you look at any of these sort of custom MQTT messages or stuff, is that everybody does their engineering units differently,
Yeah.
and so by standardizing a lot of these little pieces, you can get a lot of interoperability just because you've got all these little common components that are being reassembled in different ways. And the other part of when you're dealing with these information models that vary from server to server, one of the key values of OPC UA is the ability to browse and discover. So you can browse the type system. You say, okay, this, and you can build a panel against this, and you've got descriptions coming back from the server giving you hints on what this stuff is for. So you can go through a manual process of configuring an application to talk to a specific server, but you're just configuring it. You're not programming because the actual communication is all done using standard UA calls. So you go through, you do the browse, you get back a bunch of nodes. They say, okay, I got a node that's called motor, and underneath the motor, I've got a property called RPM. I've never seen this information model before, but I'm pretty sure that particular property is the revolutions per minute.
Yeah, exactly.
And so you can do those kinds of ad hoc configurations and still get a huge amount of value out of OPC UA. Now,
Sure.
if you want to really benefit from the information models, like to get the maximum value, you need these industry verticals that where you have multiple vendors getting together. I've mentioned those a number of times, and they agree on a common model, and they get a bunch of clients and servers developed. And now you're at the situation where you can go buy these custom clients from or custom servers from different vendors and just plug them together, and they interoperate based on this on a much higher level because the information model is there.
Yeah.
So if you've got the what we've been doing, we sort of realize that that's what's to happen. So what the working group is doing, or what the OPC Foundation is doing, is encouraging vendors that have an interesting vertical use case to get together and talk to each other.
For sure. I think the communication is the key when you work in very
Y-
different teams. So,
Yes,
yeah.
and the other course, the aspect of it is obviously compliance testing. And what we've done is we've got this very generic compliance tool. It's all script driven. So what's happening now is a lot of these information models, we're also developing testing for specific information models. So when
Interesting.
an MDIS product, they have to get certified, and they go to the lab and they get, I can't remember if they're doing their own testing but anyways, they go to the lab and they use the tool, and it's tested against their model. It's not the generic UA test, and that's another way that we make that we're working to make sure that
Yeah.
um, people can get maximum benefit out of the information model. It's a big topic. It's complex.
It
It's
is.
difficult to move big companies in this in the
Yeah.
OT environment, but so it takes time.
Oh, yeah.
But we've been seeing steady progress.
That's right. That's good. I mean, slowly but progressively. I know,
Yes.
especially as you said, in big companies, the bureaucracy and paperwork is always a slow down things, but it's good that they move at least. So
Mhm.
the next question that I received was, we all know that OPC UA supports different protocols, right? Like multiple communication protocols like TCP, HTTP, MQTT, several others. So, do you find this challenging in terms of security, and how does the working group ensure the consistent security and performance across these different transports because they have different mechanisms and so on?
Well, when you're talking about security and performance, you're really limited by whatever protocol that you happen to be using, and so you have it's up to the factory owner to make trade-offs. It's just there's only so much you do. TLS is TLS. MQTT is MQTT. You can't sort of layer on. Like, yes, we can do end-to-end. If you're using OPC UA binary, you can do end-to-end security over a broker. You're not going to get that with OPC UA JSON. Um, we've got some stuff that we're looking at, sort of standardizing that, but then there's a whole bunch of technical issues that come up in terms of making sure that everybody understands it, because there is no standard for encrypting JSON that
That's
can
right.
be done consistently. So yeah, so as I mentioned before, is OPC UA's focus is on information interoperability, in the belief that protocols are basically a consumer good now. There's lots of them. People are going to use them for different reasons. But if you get the same information going across, then then you can get some decent interoperability. And each protocol is going to have their own individual security challenges. But in some cases, we can reuse it. So, for example, if you have a OPC UA servers being issued a certificate, that certificate can turn around and be used to connect to the MQTT broker. So you're killing two birds with one stone.
The next question that I have, so we already briefly touched on the pop-up model, the new pop-up. So I think that the additional pop-up model in OPC UA is really a major revolution. So what are the performance and scalability benchmark when using PubSub over MQTT or perhaps AMQP compared to the traditional client server model? Have you like, is there any something benchmark like that?
I dislike it when people put too much emphasis on benchmarks, because benchmarks are so dependent on your assumptions that went into the benchmarks. I could design a set of benchmarks that would make NQTT look like crap and client server look wonderful, or I could do it the other way. Just tell
That's
me,
right.
just tell me what you want to see, what the results that you want to see.
That's right.
and,
That's
and this is not, and this is just by making different assumptions in terms of how the data is supposed to happen, how things are supposed to happen. So the fact is, there are a set of applications which benefit from client server, and there are going to be a set of applications that benefit from, or a set of use cases that benefit from MQTT, and there's going to be a set of applications that need to have both. And it really depends on what you're trying to do and what you're trying to accomplish. And that's why OPC UA focuses on supporting it. And so I mentioned before about the laboratory analytics people. They looked at brokers, they looked at MQTT, and they realized for their particular requirements it wouldn't meet them. So they're doing a client server through the cloud, and it works great.
yeah. That's great.
But that's them. They have a certain problem they need to solve. Other people, hey, I just want to pump up this data into the cloud so I can do some uh, analytics, sort of on a sort of some sort of data lake going on there, and for that, oh great, let's just set up an MQT broker, send your pub sub messages out, and fire them as fast as you can, and that works great, and so that's how we view the world, and one of the best, in most cases, every application that's running on a device has a need for configuration and has a need for runtime operation. In most cases, configuration works well with client server.
That's a good way of putting it out there. Yeah. I think,
But
yeah, I also, sorry for interrupting, but I
yeah,
also totally agree about the benchmarking because it's funny to see if you look, check different, for example, MQTT broker website, everyone say, my MQTT broker is faster, the data throughput is higher. So it's very challenging, and that's something could be misleading, and customers and end users should pay attention to that, not just buying that, yeah, someone did a benchmark and it says, MQTT is faster than TCP or whatever. I mean, really. So, yeah, it's very challenging.
oh, and what annoys me is a lot of times they'll throw up these graphs, but they give you no information about how they came up with those numbers.
That's
And
right.
I'm looking at them and I'm saying, and I'm thinking, you know, I bet they put a 16 byte an MQTT message with a 16 byte, sorry, a 16-bit integer, and that
Yeah,
was all that was in it. And they sent it as fast as they can because that's how they would get those numbers. And of course, if you did that with OPC UA, it's going to look like crap because OPC UA is designed it for sending data in bulk.
that's right. Yeah,
So it's
exactly.
like the benchmark was designed to make OPC UA look as bad as possible because they broke everything up. And of course, if you went and did it in a more reasonable situation, like who sends 16 bits at a time? That's not a realistic benchmark.
That's true, and I think it's not just about the communication protocol, MQTT and OPC. In any industry, this is the benchmarking is challenged because I was reading an argument on LinkedIn about two device manufacturer. One of them was LoRaWAN manufacturer. The other one is another one, MIOT or MIOT that you call them. So the one side was saying, my performance versus the power consumption is way better than you, and the other one say, no, that doesn't make sense. How did you do that? Like, you provide some background information. So it's very challenging. So, and that was a good call. So if you watch this, if you see a benchmark, always ask for the background. Like, what's the condition? Like, maybe they just did that benchmark where the other side doesn't work very well, but there are just huge other problem in the protocol or system that hasn't been covered in that benchmark. So the next question, one of my question actually, I don't know any much about it. So we know that OPC UA uses binary encoding, right? So
Yep.
why doesn't OPC UA use something like Google protobuf encoding instead of binary encoding? Is it like difficult to implement technically, or are there any inefficiency that you discovered? What do you think about that?
Okay, well, I'll give you the first answer. I've already prototyped using OPC UA over protobuf. Took me about 3 days to get it up and running, basic running. So basically, we could run it over protobuf if there was a business need tomorrow. So it's not. There's no reason why it couldn't be done. The question is, why would you want to?
That's right.
And now, just for interest, OPC UA predates protobuf. So it's like, oh, everybody think, oh, protobuf's been around for 20 years. Well, OPC has been around for longer. And but more importantly, a lot of people don't realize this, is what when you are developing an international standard that you want it to be submitted to a standards organization like IEC, you can't have your standard dependent on some open source project published by a private corporation, even if that corporation is Google. You need to reference if you're going to reference another standard, it's got to be properly managed by some sort of organization that operates like an SDO.
That's right.
And the IEC just would trying to put protobuf in. Now protobuf, I believe, has evolved to the point where they can qualify to meet the IEC standards, but that wasn't true 10 years ago. Certainly wasn't true 8 years ago.
Okay.
So that's something that a lot of people don't realize when they're not involved in the standard development process. You just can't. It's Some things you just can't do. But when it comes to the efficiency question, whenever you're developing a binary protocol, it's always a set of engineering trade-offs. And you got to decide what your priorities are. And then you pick your protocol based on what your priorities are. So the simplest answer is if your priority is you want as little data on the wire as possible, then guess what? You're just going to zip something. You're going to come up with a really good compression algorithm. But you're going to take the hit at the beginning and the end because you're using a lot more memory and CPU to basically do the compression and decompression. But if your priority is you want fast processing on low-end devices, then you've got a different set of trade-offs. And that's what OPC UA was focused on. We wanted a protocol that if somebody was developing a code in NCC on a small device, they can handle it very easily. It's a one-pass decoding. You don't have to read the entire thing and then read it again. All the elements come in a fixed order. Protobuf and JSON don't. You have to be able. You don't know what you're getting until you've got it. Whereas with UA binary, you get told, okay, you're going to get field A, field B, field C in exactly that order. And when you get to field C, it happens to be an array. We're going to tell you exactly how many elements are in the array before you get any of those elements. And so it's very good for those classes of devices. But the other very important feature that didn't exist in a lot of at the time when we were doing it, and I'm not even sure if it exists in other binary protocols right now. I don't believe it is there in protobuf. Is the decoders can choose to defer coding part of the messages. So one of the problems with binary decoders is that if you don't have all the information that you need to decode the message, you have to throw up. You say, I can't do anything with it. But we carefully designed UA binary protocol to say, okay, well, I don't understand this particular part of it, so I'm just going to skip it and I'll send it up. And then an higher layer, they might be able to deal with it. And you can't realize how important this capability is if you're designing an ecosystem where you want people to create custom data types on the fly, where you can't depend on schemas being distributed in advance to all participants. And so now what happens is you've got a lot of UA applications where they're able to consume binary data described by a schema which they didn't know in advance. They weren't compiled to know about it in advance, and they simply go to the UA server address space, get the schema definition, and now they know how to parse the binary.
So back into the topic of OPC UA over MQTT. So question that I personally have, is OPC UA over MQTT a standalone protocol, or and also another topic or controversial topic that is going on about the lightweight being complex and so on. And is OPC UA over MQTT is more lightweight than client server? And what are the key similarity and maybe differences between the client server and OPC UA over MQTT?
Well, okay, with OPC UA over MQTT, you can view it as a standalone protocol. In fact, we deliberately designed it in a way because we wanted to say, hey, if you've got some dead simple little temperature sensor device where you're never going to put an OPC UA server down there, you just start pushing out a temperature every 10 seconds or something like that, then you can just hard code your message and you can send it out. So literally, you're just sending out a short JSON message to a pre-configured MQTT topic. In fact, I wrote a series of articles on LinkedIn that sort of walk through how you sort of these different tiers of applications, talking about how at the basic level it's very simple, standalone, not dependent on anything in UA, and you can get something you can write. You can do something that's technically UA compliant as fast as you could write your own custom code. Now, advantage of doing it the UA way is the ecosystem. Now what happens is, okay, you're pushing out this data now, so okay, so it's going out with a specific, you've got a specific metadata format that you're publishing. Now all the UA subscribers can now consume this, so now they can understand what you're sending to them. You're publishing your discovery messages using the standard UA way. Now your subscribers can discover where you are. That's one of the big limitations of MQTT. They don't have any built-in discovery mechanism. And or you want to be able to publish whether you're up or where you're alive or not. So again, standard UA way to do that. Again, easy to implement with very simple messages, but by doing it the UA way, you're able to leverage off the infrastructure of standard clients. No custom coding needed on the other side.
Okay, perfect. And just a follow-up question about OPC UA over MQTT. And I think there is a term that is being used that is called report by exception. So do you see OPC UA over MQTT or pops up a report by exception protocol, or is it based on the polling basically?
Oh, this is another one of those things that's been
Buzzword,
going
yeah.
around that just makes my blood boil. OPC UA is exception based. Full stop.
Yeah.
Anyone who says otherwise doesn't understand OPC UA. And in some cases, yeah, so but to understand what's going on, you have to realize that this is where some of our experience in industry, in the OT environment for the last 25, 30 years is sort of becomes understanding that background is important. We know that OT users want to know when something goes wrong quickly.
That's right.
They don't want to have to wait 5 minutes to find out that something has gone offline. So not only do we have error detection built into the protocol, we've got multiple layers of error detection because we know from experience that just because you can get to the server doesn't mean the subscription mechanism is still running. So we've got different layers. So what this ends up happening is you have all this traffic that ends up on the wire. So if you throw a Wireshark on it, you look at all the traffic going between a client and a server, like you just install one with their default configuration. You see all this, oh, it must be pooling. No, it's sending a whole crap load of keep alives because by default, OT users expect fast detection of errors. So that's what everything ships with the default. Now, point is, if you have an application where you can honestly say you don't want fast detection of errors, and you just want to minimize the amount of traffic on the wire, then you can turn off all that error detection, and the only thing you'll see on the wire is data changes.
That's good. I think that was one of my question about can it be customized for a customer who don't need these certain features. So that's great to know it can be customized. So
yeah, and the only time I've ever seen it customized is when somebody needed to send data over a slow satellite link.
I see. Yeah.
In most cases, people want the reliability, and of course, if you talk to people who've been trying to develop MQTT-based solutions, they realize pretty quickly that they do need error detection that goes above and beyond the will message in MQTT.
For sure.
So they're interlisting their own custom keep alives. And this is a good example of how people can come in, they say, oh, look, everything's so simple. And then all of a sudden they realize, oh, well, I kind of need this feature. So now we're going to put it in. Oh, guess what? We already know that. We already built it into the spec.
Yeah.
Exactly. We knew you would run into that problem.
Exactly. And I think many MQTT examples are very simplistic, I would call it, and don't really utilize features like quality of service or QoS, which are really needed in real life industrial application. So a question that I had here is, let's say in a raw MQTT system with just one publisher and one subscriber using, let's say, QoS 1. Would there be fewer network exchanges compared to an OPC UA client server setup exchanging the same amount of data? Again, I'm not sure you've done any tests, but what do you think about that?
Well, okay, well, just initial caveat. There is no ability to set up configure a publisher to send data in PubSub or any sort of MQT communication. It's basically the subscriber has to take whatever the publisher is deciding to publish. So once you set up your subscription, so in client server, you have to go through a bunch of handshakes to create your subscription, pick your variables, and basically set everything up. Once you've done all that and you're basically got your stream reporting data changes, then the network traffic is identical to MQTT QoS1. And so you've basically got act, everything has to be act, and that's what you end up with. Now, obviously, we don't. If you don't want QoS1, you want to get things down to the minimum, then you can go to PubSub. In which case, you can just blast your data out there and don't really care if it gets to where you wanted it to go.
That was a great point. I think again, as I said, like a lot of examples that I see about like saying, oh, your MQTT is lightweight and fast. But I said, yeah, you are not just using any feature of the MQTT. Just try to build a complete solution and then compare. Because
Yeah.
OPC UA or something like that is a complete framework and solution that considers all those keep alive, error, handling and everything. So of course, if you don't have those, you have less data on the wire. So that
Right.
was a
And
good
and
call.
and yeah, and those are repeated again. Just because you don't think you need a particular OPC UA requirement today doesn't mean you won't realize you need it in the future.
That's right. Yeah, might not be the hard part of the project requirement, but maybe for the next project or when you are integrated to someone else, you need all those. So another question, Randy, I think is very interesting and important these days in the IIoT and Industry 4.0 project, particularly because any device or piece of software in IIoT world normally talks to a cloud, right? A
Mm-hmm.
question that I had is when we use OPC UA to publish some data to the cloud, what inbound and outbound port should be opened on the node side? And how about the flat MQTT, Sparkplug B, or any other protocol? Or the short question would be, is that the truest statement to say when you use OPC UA to send data to the cloud, you need to open a bunch of ports, but you don't need those when you use MQTT? Is that the truest statement?
No, it's completely false. It's the thing is, for starters, well, OPC UA over MQTT is an option. So if you wanted to set up an MQTT broker and use that to push all your data to the cloud, that is an option. You're just making sure all your messages are formatted in using OPC UA mechanisms. So, but if you're using client server, we have this interesting feature that is actually surprisingly well used. Like I talked to the SDK vendors and they say, yeah, we got a lot of customers using this feature. I didn't think it was going to be that interesting, but apparently it is gotten a lot of uptake. Basically, the server connects to the client in the cloud. So it opens a socket. So what you have is a outgoing socket to a cloud server, nothing incoming. Now, once you've got that outgoing socket, the client can turn around and start and basically set up its subscriptions to everything it would otherwise. So it avoids the problem of opening up incoming ports because once you've got the socket, it doesn't make a difference which direction the communication is going. You've got the socket. And since the server initiated from inside it, you're only opening up the outgoing. And of course, if you're using a standard port like HTTPS, then it makes it that much easier.
For sure. No, that's great to know because I know for example for some VPN solution from different vendors, some of them ask you to open a bunch of other ports which others don't need. So that's absolutely false statement about OPC UA.
Yeah.
Okay. Great. And the next question that I had, so it looks like different OPC UA clients and server, both hardware and software, have different performances. For sure, it depends on the basically the vendors and the implementation of the OPC, right? The question that I had here was, is there any official reference or sample codes for testing the performance of OPC UA client server or pops up for those who want to, let's say, do one of those controversial benchmarks? And is there any particular hardware that you recommend for those who want to do some testing on that OPC UA?
There's such a huge variety of use cases. You can't say that there's one recommended. People really have to say, what problem do I have to solve, and how can I design a set of best benchmarks and pick the right hardware and software that is relevant to my benchmarks. So if you are developing embedded devices, then you would want to pick an SDK, an NCC SDK to do your benchmarks. If you are expecting to do C# or Java development, then you would be using SDKs that do that to do your development. But the short answer is, if you need to do benchmarking, pick one of the SDKs to develop your code. That's the quickest way to get it done. But also remember that you pick the SDK based on what your requirements are, and pick an SDK that's so if you want to, you can go and get a Python SDK and do all your, and a lot of people do testing with Python stuff. It's a very common thing. But if you want to do benchmarks, well, the Python SDK is unlikely to be your most performance solution.
Yeah, I think Python, because it's just simple to use, maybe that's why kind of got a lot of popularity. But
Classic engineering trade-off: ease of
yeah,
use versus performance. And
exactly.
yeah, and it comes down to that a lot of times.
That's right, yeah. And the next question, I think you already touched on the keep alive signal and troubleshooting and so on. But do you know how long does it take to detect that an edge device which run OPC UA has gone offline in OPC UA basically compared to other protocols? Like, can MQTT alone even handle this task at all?
Well, okay, the way it works with MQTT, they've got this thing called a will message, which the OPC UA over MQTT takes advantage of. But that's going to have some timeout, and it's probably going to be in minutes. It's unlikely to be 5 seconds or 10 seconds. The OPC UA also allows you to simply do a keep alive mechanism instead of a will message. And so that could be potentially faster. So basically, you say you're sending a status message every 5 seconds. So if the subscribers aren't getting an updated message for 10 seconds, they would know that, okay, this source has probably gone offline. But those would be configured based on the needs of your application. Obviously, client server, it's got multiple levels of keep alives. You can dial them down to give you some pretty rapid detection. But a lot of times, the defaults are detect within 30 seconds or so, which is more than adequate to keep a human user happy when they're looking at an HMI.
For sure. And for remote and telemetry and remote monitoring application is very normal. So perfect. Thank you for that. And just a very maybe quick question. I'm not sure if this is known or has any test has been done in this aspect, but do you know if there are any scalability limits in terms of nodes and number of clients and server in a very large scale industrial system? Is there any known limitation?
The limitations come from your actual hardware infrastructure. There's nothing inherent in the protocol that is going to put a limit on you. So, obviously, if you're using client server model, there's a number of clients, simultaneous clients, was going to max out because you're using a socket for each one of them. But if you have a huge number of clients, you're going to go to pub sub. So basically, you pick the protocol that suits your requirements. Um, so yeah, it's so there is no limit as far as I know, but there is always going to be a limit based on your network infrastructure, and those decisions are generally outside the scope of OPC UA. Of course, obviously, a lot's going to depend on the server. Some servers
Yeah,
are only designed for certain things, and that you're going to run into problems. But yeah, so
definitely.
nothing.
The next question that I have is a topic that I don't really know much about and I haven't done much research, but it's a hot topic in the OPC UA world, which is OPC UA over TSN. So just wanted to quickly ask, in real time or near real time application like we know robotics and overall motion control application, how does OPC UA handle these constraints, and is there any work being done to reduce latency in a network that is using OPC UA?
Well, the entire FLC initiative has been focused on developing standards, OPC UA extensions to OPC UA that are focused entirely on meeting the needs of these real-time applications. So it is adopted UDP as the low latency protocol, and it's also designed to work directly over TSN. So a lot of the constructs that are kind of built into the pub sub over UDP, they do some things that might be seem a bit odd for somebody who's familiar only with UDP, but is baked into the protocol because of the need to support TSN. So we have a lot of, and that entire group had a lot of people with a lot of experience working with real-time applications, providing feedback to make sure that what we're putting together will meet the needs of those classes of applications. And very optimistic in terms of how that's going to. We're seeing lots of vendors ramping up their implementations now.
And the next question about the overall the programming languages and SDK. You already mentioned there are some SDKs that user can go and get them and start building their stack and implement their own OPC UA. But I wonder if there is any plan to support OPC UA both client server and pops up for more generically used programming languages like Python, like similar something like a library like Eclipse PAHO MQTT from the Eclipse Foundation. What do you think about that?
Well, okay. Well, there is a Python SDK out there.
Okay.
So you can search on GitHub, and you can probably find. In fact, I actually worked on a project where it was developed a client entirely using Python, and so that one is covered off. And the PAHO MQTT, well, that's just a broker. So the samples we have, you can drop in any broker. I believe we use the Hive one because it's just convenient, and as well as the Mosquito one, but any broker could work. Now, what we're doing with sort of as part of the cloud initiative is we're sort of focusing on providing examples in a larger number of languages that we've had in the past. And so we'll be releasing some of these shortly, and they will include Python, include TypeScript, include Node.js, include obviously .NET and Java. So we'll cover all of the major ones in terms of providing programming examples and really trying to reduce the entry point. And I'm actually kind of excited over some of the stuff that we've got with our Swagger based definitions, that I think people are going to find that a much lower entry point to get into the UA world.
That's right. I think that would be really helpful to have that. I think one of the main reason maybe first time I started using MQTT was just, there was a library in Python. It was just easy application examples and just publish some data. It's just easy and everyone's happy. So it's good to
Yeah.
see that there are a lot of SDKs in different program language for OPC UA as well. So I think I have around 4 or 5 more questions, and there are more questions that have been asked by the community members. So Richard on LinkedIn asked, are there any plans to simplify the creation of structured data types in OPC UA without needing extension objects or node sets files? Considering how common structured data types are in PLCs, the current methodology feels like a major weakness. Do you agree with that, or what do you think about it?
Well, okay. A couple things there. You don't need a node set file. What you have is the structures can be described by the data type definition, which is an attribute on the node. And in PubSub, for example, there's a bucket for a data type definition, and you can create a bunch of custom structures and put them into the metadata messages that you publish with your MQTT messages that have no node set. Node sets aren't involved at all. So, so it's the node set is it was something that was developed to support companion specifications with OPC UA. When you're dealing with any sort of dynamic structures, the expectation is you use the APIs that are available, and you're not going to be fiddling around with node set files. I'm not sure about the concern about extension objects. Extension objects are what is used to allow um, a receiver that doesn't know the custom structure to be able to deal with it. So with PubSub, we've got a couple options, and you can actually strip out the type information and just send the raw body. So you end up with a very simple looking JSON message, which if you just want to manually process it, it's fine. So that's an option today. With client server, you're always going to have the extension objects when you're reading values of variables because that's just the way it works. Like I said, I don't understand why that particular aspect of the problem is a concern to them. But the short answer is no, you don't need no set data types. The actual mechanisms that are baked into the specification are very simple to use. You can describe a structure with something that's equivalent to a JSON object, and you're done, and that can be consumed.
Perfect. So the next question from Rick on LinkedIn. Is it possible to subscribe to OPC UA data from a browser or web browser in a standardized way? How can we easily query OPC information models in JSON format from a browser in a standardized way?
Well, there's actually a sample that's up on the web right now, which loads up a web page that will allow you to browse a UA server using the standard interfaces,
Okay.
using JSON on the wire, TypeScript application built with React Type. So that's available there. It'll be publicly available. The code will all be made publicly available fairly soon. Definitely by the end of November. Um, so so the short answer is yes, we've been doing a lot of the work. It's all part of the 1.0504 specification, which will be coming out very soon. And now in terms of the information model, yes, you can do all your browsing, and you get your information model by browsing rather than node sets. We've had people that have had asked for a JSON equivalent with a node set, but there's a lot of complicated arguments over that particular problem that I won't get into right now. But the short answer is, actually, one thing that I just finished was we will be updating I've updated the tooling that's generating all the stuff. So what will happen now is all the data types for a companion spec will have a Swagger definition that defines them using Swagger, like OpenAPI. And the value of this is so it's a bit of a hack in a sense because you've got this dummy get service that you're never calling. But the point was now you could pass this Swagger file into the standard tooling, and now you can generate a bunch of classes that for all the data types that were in the companion specs. And this will be a tooling that will be available for anyone developing information models. So these are some of the pieces we're putting together, and we're focusing on providing the pieces that meet specific use cases. In this case, somebody developing a client that we want to consume a structure information from the server. So in this case, you'd say, well, give me your Swagger definition as opposed to your node set.
Okay. That sounds interesting, and it's good to know So you think it should the sample application should be out by end of November or maximum end of this year?
Yes, yes, it's one
Perfect.
of the things with software. It's the last 10% always seems to take a lot more time than you
Exactly.
expect.
Yeah. All those testing and making sure everything works before publishing. Totally makes
Yeah,
sense. Yeah.
yeah.
So I have a couple more questions from the community. Caleb asks, are there any plans to leverage OPCUA over modern transports like NATS, gRPC, ZeroMQ, Kafka, Zenith, and instead of MQTT?
Yeah, I love the modern transports. It's anyways, well, that's actually one of the value of the entire OPC UA infrastructure. And we we've always said that the actual protocol is something that people should pick based on other needs, that's the information exchange that matters. We are we've been providing mappings for different things. So we got a mapping to MQTT, but what we're doing now is we're getting an appendix. I'm not sure it's going to get into this version of the spec, but it will go into the next version for sure, which basically gives you some rules for using any kind of middleware. So if you come along and you say you've got this wonderful message-based protocol, here's a set of rules that you be able to use to send it over this whatever your message-based protocol is, and because we're standardizing at that level, then another client or another subscriber will be able to ingest that without having to do a lot of additional work.
And the last question that I have on my list, again from Sergio on LinkedIn. How does OPC UA handle the store and forward functionality where an RTU or a device or edge device buffers the data when communication is lost and reports the real-time data when communication is reestablished? It looks like this functionality is available in some telemetry protocols like DMP3 and IEC 104 or even MQTT or Spark B.
Yeah, well, again, if you're using OPC UA over MQTT, then you get everything that the broker provides, which it would include any sort of store and forward. Although that's very limited what you can do with that. Especially if you're using QoS 0, you tend to lose. If you have to be using at least QoS 1 if you want any sort of reliability. Now, if you're using client server, there's a mechanism in the specification called durable subscriptions. So what this does is it's buffering. It's providing a much longer buffer of notification messages. So what will happen is that these notification messages will get saved to disk, and if you've got a client that's disappeared for a particular time, they can reconnect, and then everything that they missed will be sent to them.
Sounds good. Perfect. Yep. Thank you very much. I think, oh wow, we've been talking around 2 hours. Yeah, time just flies so fast. It was a very interesting discussion, at least for myself. And I don't have any more question on my list, but if you want to add more points, or if you want to answer any question that you have heard personally that wasn't on the list, feel free to mention that in the closing words.
Well, I'd like to thank you very much for giving me this opportunity to talk. It's been a good discussion. I hope people have been able to get something from it. I guess we're always interested in feedback and hearing what people want to hear. Obviously, it's a lot of times we can't act on everything, every good piece of thing. We can't act on it immediately. We can't solve a problem tomorrow, but when we hear something, we pay attention and uh, and we start moving. We start moving in the directions when it's clear that is, and this is what we've been doing all along. And people don't realize how much OPC UA has adapted over the years as technology has changed.
Yeah.
So
No, I totally agree. As someone who's been using OPC, I mean, as a data access at least in more than a decade ago, it's been interesting and a fun run to see. And also, what I really like that you guys are kind of on top of the latest tech. And by introducing the PubSub, for example, it's good to see what are in the market and basically adopt all their standards based on those. So yeah, thank you so much again, Randy. It was a pleasure talking to you, and looking forward hopefully to more discussions in the future. And for sure, I think we will get some maybe follow-up question from the readers and listener to Block IoT, and I'd be more than happy to get your answer on those, and I'll forward them to you. So thank you so much again for your time. Really appreciate it, and yeah, thank you again, and have a great day.
You have a great day.
Thank you.